Numbered here. Today I'm going to be doing Unit 6 Notes 2. So I'm going to be talking about the geometric mean between two numbers. So we haven't really talked about this much as of yet. So we're going to kind of look at what this means and learn how to calculate it as well. So let's just go ahead and let's just talk about the geometric mean in general. Now you'll notice that we have on each side of a proportion the same number that's on bottom of one fraction and is on the top of the other. Now that number that's on the bottom of one and on the top of the other fraction is the mean itself. Then we call the other two numbers that are different the extremes. Okay, so then let's go ahead and let's take a look at this. So the mean in general, when we talk about it, means the altitude or the height. Okay, so I'm just going to put that in parentheses, the height. Okay, when the means of a proportion are the same number, the number is called the geometric mean of the extremes. So that's what we're going to be learning to calculate today. So here's one way you could look at calculating the mean. Well, if you were to solve this, you needed to cross multiply. So x times x is x squared, and that's equal to a times b. So take the square root of both sides, and we get that, or a, apparently, we get that x is equal to the square root of ab. So that's really a really important formula that we're going to be using for the geometric mean. That x is equal to the square root of ab. So you're going to want to make sure you have that written down big and bold so that you remember it, because it will help us down the road here. So let's go ahead and let's take a look at number 1. It asks us to find the geometric mean between 8 and 10. So what I'm going to do is I'm going to again use that formula x is equal to a times b. So if we're looking for 8 and 10, well, x is going to be the geometric mean. So 8 and 10 are going to be my a and b. So x is equal to the square root of 8 times 10. So x is equal to the square root of 80. We'll take the square root of 80 and you get 8.9. So that's the geometric mean between 8 and 9. Now let's take a look at the geometric mean between 9 and 14. So x is equal to the square root of 9 times 14. Well, you multiply 9 and 14 and you end up getting, I did 9 and 4 on my key. 9 and 14, you end up getting the square root of 126. So then we're going to go ahead and take the square root of that answer. And when we do that, we end up getting 11.22. So that is the geometric mean between 9 and 4. So let's go ahead and let's take a look at this into practice. So now we're going to actually apply it to triangles. So you can use it to find the altitude of a right triangle. So this is the altitude. It's the height. So altitude is going to bisect the hypotenuse angle, so the line, into two 90-degree angles. So basically what we're making is 3 right triangles with our altitude. So we're making 3 right triangles, or angles, triangles. There we go. Okay, so then all of these triangles are going to be similar to each other. So here's what I do. Okay, so here's what we know. We know this big triangle, ABC. So triangle ABC is going to be similar to this. Let's name this point D right here, to this triangle right here, ACD. Okay? Then let's take a look at the next one. Then I know that triangle ACB, or ABC, is going to be congruent to this triangle right here, CBD. And last but not least, the two smaller triangles are congruent to each other. So then the smaller triangles are congruent to each other. So CDA is congruent to CDB. Okay? So that is your kind of similarity statements. So if CD is the altitude or the height, that's what we know. So let's go ahead and let's take a look at a theorem that we can apply to this. So if the altitude is drawn on the hypotenuse of the triangle, it separates the hypotenuse into 2 segments, like so. The length of this altitude is the geometric mean between the lengths of the 2 segments. So let's call this length x, and let's call this length y. And I'm going to call my altitude z, or my geometric mean, because that's what it's going to be. So if we were to set that up as a proportion, our short length over our altitude is equal to our altitude over our long length. Notice that because it's the mean, it's on there twice. So what does that tell us? Well, that tells us that z, the geometric mean of the triangle, is equal to the square root of x times y. So that's what we can use to get each of those values. So what you need to do when you do something like this is you're going to end up having to draw out 3 triangles. So I always draw the 3 triangles in the same order. I do the long side here, I do the short side here, and I do the hypotenuse here. So then when I line them up, boom, 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 it makes it really easy to see that they are, in fact, similar triangles. So let's go ahead and let's take a look at another theorem. So we're going to talk about the geometric mean leg theorem. So the altitude drawn to the hypotenuse of the right triangle, like so, separates the hypotenuse into 2 segments. The length of this leg of the triangle, so we'll call this x, and y and z again. So also, likewise, not only is the altitude the geometric mean of the 2 lengths, but the leg is the geometric mean between the hypotenuse and the segment of the hypotenuse to the adjacent leg. Oh, that's a lot of confusing words. So let's write it out easily. Okay, so CD is going to be our altitude. Okay, so we know here that my altitude is going to be x, or is going to be z. So I know that the length of the leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse of the adjacent leg. So that means if I'm going to take length x, I can write that twice. Okay? And then that's going to make sure that B and Z, so it's going to work out that way. Likewise, if I put Y here, it's going to be the same as A and Z, like so. So we can use, again, that geometric property to help us. So this is a lot of information thrown at you at once. So I think it's easier just to take a look at concrete examples of how we're going to use this. So here's my big triangle. So I mentioned to you guys earlier that I always draw my triangles out the same way. So what I do is I draw a large, a medium, and a small triangle. And then I just set up the letters. So I'm going to do my large triangle in blue. So that's going to be this big guy right here. So the long side of my big triangle is Z. The short side is Y, and the hypotenuse is going to be 5 plus 20. And I know that, remember, because the hypotenuse sits across from the right angle. So this is going to be 25. So then what I'm going to do is I'm going to take a look at the medium triangle, which is going to be this guy right here. So my short side is X, my long side is Z, and, oops, sorry, Z is my hypotenuse. Come on, Miss Hubbard. Okay, so here's my right angle here. So my long side is 20. And then if I look across from the right angle, my hypotenuse is Z. So last but not least, we want to take a look at our small triangle. So this is my small triangle right here. My short side is 5. My long side is X. And then Y is my hypotenuse. Okay, so now I want to calculate out a geometric mean. So what I notice here is I have 20 and X and 5. So I can actually, if I look at this guy, X is the geometric mean of these 2 shorter sides. That's that first theorem that we talked about, was that the altitude of the triangle, so let's just take a look at that. The altitude of the triangle is the geometric mean between those 2 numbers. So it means that X is equal to the square root of 20 times 5. So then the 20 times 5 is 100. So then I get that X is equal to the square root of 100, which is 10. So I know that X is equal to 10. And now I need to find X, Y, and Z. So I'm going to go ahead and I'm going to erase X, and I'm going to write 10 in instead, since I know what 10 is now. So what I'm going to do first is I'm going to focus on this triangle right here. This triangle has 10 and 5. So what I have is a right triangle, and I know 2 of the 3 sides. So to get Y, I'm going to go ahead and use the Pythagorean theorem. So I'm going to use my 2 legs, which are 5 squared plus 10 squared, and that's going to be equal to my hypotenuse squared, which is Y squared. Well, 5 squared is 25, and 10 squared is 100, and that's going to be equal to Y squared. So Y squared is equal to 125, so I'm going to go ahead and take the square root of both sides. The square root of 125 is going to give me 11.18. So that's going to be my Y. So now that I found the geometric mean of x, I also see that this second triangle here, I have, for z, I have 20 and 10 already written into that second triangle. So again, I can use the Pythagorean theorem. But now my legs are 20 and 10. So I have 20 squared plus 10 squared, and that's going to be equal to z squared. So then I have 400 plus 100 is equal to z squared. So then I get that z squared is equal to 500. So I'm going to go ahead and take the square root of both sides. And when I do that, I end up getting 22.36. So that's my final answer for number 3. So I have my x, my y, and my z. Now, let's go ahead and let's take a look at number 4. Again, we want to find the x, the y, and the z. So here's my right angle right here. So I'm going to go ahead, I'm going to draw my large, my medium, and my small triangles. So now what I can do is I can go ahead and write out my values. So here's for the large triangle. Okay, my short side is z, my long side is y, and my hypotenuse is x plus 9. Now, let's take a look at my medium triangle. So for my medium triangle, that's this guy right here. My short side is 12, my long side is x, and y is my hypotenuse. Finally, last but not least, let's take a look at my small triangle, my little guy. So my short side is 9, my long side is 12, and my hypotenuse is z. So now what I notice is they're actually giving me the altitude. So this altitude is the geometric mean between x and 9. So don't let that confuse me. All that tells you is we can do 12 is equal to the square root of x times 9. So we're going to go ahead and solve that equation. So 12 is equal to the square root of 9x. So now to undo a square root, you need to square both sides. So then I get 144 is equal to 9x. Then I'm going to go ahead and divide both sides by 9. And when I do that, I end up getting that x is equal to 16. So now what I'm going to do is I'm going to cancel out all of my x values. So this x value is going to become 16. Well, this x plus 9 I'm going to erase, and x plus 9 is going to give me 25. So now I know that this value here is 25. So let's go ahead and let's take a look. So let's take a look at y to start off with. So I notice that this triangle right here, I have both legs and y is the hypotenuse. So that means I can use the Pythagorean theorem. So 25 squared plus 12 squared is equal to y squared. So 25 squared is going to give me 25 squared. Oops, that should be 16. Boo, 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 because that's the leg. I looked at the hypotenuse of the other triangle. So 16 squared is going to give me 256. 12 squared is 144, and that's equal to y squared. So then I get that y squared is equal to 256 plus 144. Well, you add those together and you get 400. So to solve for y, I'm going to take the square root of both sides, and that's going to give me 20. So there I get that y is equal to 20. So now what I'd like to do is solve for z. So I notice I have 9, 12, and then I have z as my hypotenuse. So since I have both of the legs of that triangle, again, I can use the Pythagorean theorem. So 9 squared plus 12 squared is equal to z squared. So then I get 81 plus 144 is equal to z squared. So when I add those two together, I end up getting 81 plus 144 is 225, and that's equal to z squared. So take the square root of both sides, and I get that z is equal to 15. So now I have each of those three values. So let's take a look at number 5. Number 5 is just a little bit different in that all we need are our large, medium, and our small triangles. And we actually don't even have to write it out because all we're looking for is w plus 4. Well, we know that w plus 4 is the geometric mean between those two numbers. So we can use that to solve. So w plus 4 is going to be equal to the square root of 24 times 6. Well, the square root of 24 times 6 is going to be 144. Yes. There we go. The square root of 144 is going to be 12. So now I need to solve this for w. That 4 is being added, so I'm going to subtract 4 from both sides, and I get that w is equal to 8. So 8 is my final answer for number 5. So that concludes your note video for today. Thank you for listening.